For the last two formula for this lecture, we have that the integral of sine is going to be negative cosine, and the integral of cosine is going to be sine. So if I look at the first example here, the integral of sine of 3x, let me actually first point out that this is not going to be negative cosine of 3x plus c, by the way. So this formula only works when it's just a sine of a single x and cosine of a single x. So this is not going to be the correct answer. So to do this integration, I'm actually going to have to use the u substitution. So I'm going to let u be the 3x here. And my du is going to be just 3 dx. So now I can go ahead and do the substitution. So this is going to be the integral of sine of 3x, which is sine of u. So I change everything to u, basically. So it's going to be sine of u. For my dx, I can move the 3 to the other side. So basically, dx is going to be just 1/3 of du. So here, I'm going to have the integral of sine of u times 1/3 du. 1/3 is a constant, so I can pull it out. So that's going to be just 1/3 times the integral of sine of u du. And now I can go ahead and use the formula. The integral of sine of u is just going to be negative of cosine of u du. Negative of cosine of u plus c. So now then I can distribute the 1/3. So that's going to be negative 1/3 cosine of u. And my u is 3x. So that's going to be negative 1/3 cosine of 3x. Plus, well, if you distribute the 1/3, you will get 1/3 c. But this c here is actually just any number. So if I multiply any number by 1/3, it's just another number. So normally, when you have something like this, I'm just going to say it's just a number c. So c can be any number, so it's the same thing anyway. So here's my answer for part A. For part B, once again, this looks like something that I'm going to have to use the u substitution. So I'm going to let my u be the sine function here. So my u is going to be sine of x. And then my du, the derivative of sine, is going to be cosine. So that's going to be cosine of x dx, which is actually what we have back here. So my integral, once I do the substitution, is going to become the integral of u squared du. And I know this is gonna give me u cubed over 3 plus c. And my u is sine of x, so I can substitute back, and that's gonna give me sine of x cubed over 3 plus 3. Plus c, okay. So here's my answer for part B. So let's do part C. I'd like to integrate x times sine of x dx from 0 to pi. Now, if I try to find this integral, the integral of x times sine of x dx, the u substitution is not gonna work here, because if I let u equal to x, then it will not do anything. Or if I let u equal to sine of x, then my du is gonna be cosine of x dx, and I'm not seeing cosine of x in this integral here, and that is not easy to make happen. So I'm gonna have to try the integrals by parts. So I'm gonna let my u be x here, and I'm gonna let my dv be this should be dx. And I'm gonna let my dv be sine x dx here, and hopefully I should be able to find u and v and do the integration by part. So my u is going to be just x, and my dv is going to be sine of x dx. So then, if my u equal to x, my du is just going to be dx. The derivative of x is just going to be dx. And if my dv is sine x dx, my v, if I integrate the sine function, that's going to give me negative cosine. So that's going to be negative cosine of x. And this makes sense, because if I take derivative of this thing, if my v is negative cosine of x, then derivative of cosine is negative sine. So the negative cancel out. So I get dv is sine x dx. So this is correct. So then I can use the formula. The integral of u dv is going to be just u times v minus the integral of v du, which is gonna be u times v is x times negative cosine of x, so that's going to be negative x times cosine of x, minus the integral of v, which is negative cosine of x, and then du, which is just dx. So here, the two negative signs cancel out. I'm just going to be left with the negative x cosine of x plus the integral of cosine of x. So the integral of cosine I knew how to find. So this is going to be negative x cosine of x. And then the integral of cosine is just going to be a sine function. Okay, so this is my integral. Let's go ahead and do this integration from 0 to pi then. So this is going to give me negative x cosine of x plus sine x. Once again, I can leave out the plus c here because I can do the integral from 0 to pi. So I do the integral from 0 to pi. I'm just going to plug in the upper number, plug in the lower number, and subtract the two things. So this is going to equal to, let me see, if I subtract the upper number, that's going to be negative pi cosine of pi, and then plus sine of pi, and I subtract this by, let's see, if I plug in the 0, that's going to be 0 times cosine of 0 plus sine of 0 plus sine of 0. Let's see what this is going to equal to. Well, to find cosine and sine of pi, let's think of the graph of the sine function. So the sine function looks like this. So sine of 0 and sine of 0 and sine of pi are both equal to 0. So this is sine of x. So sine of pi is 0, sine of 0 is 0. And the graph for the cosine looks like this. So here's the graph of cosine. So cosine of 0 equal to 1 and cosine of pi equal to negative 1. So cosine of pi is negative 1, cosine of 0 is 1. Now then, I can compute the final answer. I'm gonna have, let me see, the first parenthesis is gonna be negative pi times negative 1. So the negative cancel out, I'm just gonna be left with pi. So it's gonna be pi plus 0, which is just pi. And then minus, I'm gonna have 0 plus 0. So that's gonna be just pi minus 0. So my final answer is gonna be just pi here. So here's my example of 1.6.